Good morning, people. Let's get started. So, cloud native Toolbox for Java, right? Before we get there, I kind of want to, weir off a little bit off the track and off the script and stuff like that. So we have story time. We started this thing at work. We have like a separate channel called Inktober where you just doodle things. You just draw things. There is a word coming up every day during this month. And then people will just doodle it and put it in the channel. Others will put some emojis and, it's just for fun and stuff like that. And, before that, ask the questions about doodling and actually cloud native stuff. We're in room 4. Use that, and at the end, I'll pull it up, and then we'll go through the questions. So back to the doodling thing. So one of the days, I had a word, I think it was something called frustration or confusion or something like that. That's what came to my mind. But there was something missing there, because I was preparing for this talk, and I thought about this picture, and it was kind of something was missing there, because cloud native. And I was like, there is something missing in this picture. And then I realized what is actually the definition of cloud native? And what is a cloud? What is cloud native? And all this kind of things. And then, this joke came to mind. This drawing was born literally yesterday. After the conference, I came to my room. I did this and I added last moment. But, the actual thing is it's a kind of a bit of a disclaimer that, well, cloud is not something magical. It's just somebody else's computer somewhere out there. And when you develop cloud native applications, you don't really even have to be on the cloud. So, jokes aside and all this, let's go back to like kind of serious stuff and the topic of this talk. And what is a cloud native definition? So this is a wall of text that is probably as much text as you will ever see. If you're taking pictures, just wait. There are 2 more slides and it will be easier to take pictures of it. But, it's a wall of text and I'm probably kind of about to lose most of you trying to parse that big chunk of text. Don't do it. I kind of done it for you. I selected some words that are kind of essential for this. I actually done even more. So this is probably I removed all the other words. So now you can actually read and see what it is. But we can go even further. We can actually try to group them. So, first part talks about what are we building. We're building scalable applications, all this kind of stuff. That can run. That's very important. Can, not have to, but can, on public, private, or hybrid clouds. We are doing containers, service meshes, microservices, all this fun stuff that everybody talks about, like buzzword bingo, for some of us anyway. And why do we want to do that? Then there is another techno buzzword bingo, right? You have loosely coupled, ooh, yay, resilient, observable, yay, yeah. But there is a system to the madness. I mean, it's actually not that just buzzword bingo. It actually kind of helps. So we'll talk a bit about that. So what we'll do is to kind of look at the different parts, the why and how and what, and in the opposite direction, because, when you try to explain something, you probably should start with what. With why. Exactly, that's the opposite. People very often start with what. Oh, well, this is this thing. I was like, no. Tell me why do I need that thing, and then we can talk about that thing. So, the why. Typically, the why part is a kind of a business needs often. So people would come to me, to us, to other people, and ask us, "Can you build us this solution?" And we want it to be like this and that, and cloud native or whatever. And you would ask, like, "Yeah, okay, what's your needs?" And then it would be something. Oh, well, it's very important that it's quick time to market, short time to market. Okay, cool. we want to be able to respond easily to change and all this kind of thing. So, whenever our competitors release a new feature, we can just release a new something that can compete or something like that really quickly. And we don't have to take down the whole application and, rebuild and redeploy everything with downtime and everything. So you want to have some kind of failovers, microservices, all these kind of things that, well, we'll talk about in a bit. Obviously, you want it to be reliable. You don't want a solution. I mean, how many of you would like to use a solution that, goes down every now and then, every 5 seconds, every 5 days, whatever? Oh, it's down again. Yeah, okay, let me check the logs. So you don't want to do that. And to do that, to achieve this reliability, it's you have all these things like automation of many things. It's like it's an animal that comes in all shapes and sizes, because it's automation of builds, automation of deployments, automation of testing, automation of security checks, automation of automation, automation of automation of automation, all these kind of things. You really want to do that. Infrastructure as code, you name it. There is a lot of things there, right? You want your solutions to be scalable. You don't want to, back in the days, we would buy hardware for kind of worst day-ish scenario, and then would use like 10% of that. That's what we did when we started. When I started working, when was that? That was starting to get long time ago, but, well, 15, 16, 17 years ago, or something like that, right? We would have servers, would have application servers on them, a Tomcat or something. You would just drop jars on it, and you would hope that, it was big enough. You want your, scalable applications is an important thing now, because you don't want to use all that. You just want to use kind of the Goldilocks thing, right? Just enough, just perfect. Availability is a thing, right? Because you want to make your solutions, your applications available to many geographical locations, to many users, maybe a few users, maybe just specific kind of users, and all that needs some kind of tooling as well. And you want to, obviously, to test things, right? A couple of years ago, actually quite a few years ago, GeeCON used to hand out cups. It said, "There is no test like in production." And that was, I still have them. It's amazing, my favorite cup. Wherever you're testing, whatever floats your boat, rocks your boat, whatever, wherever you're testing, you still need something to test stuff, right? You want your applications also to be resilient. And resilience is about responding to errors. What happens when something fails? What happens if something that you depend on somewhere out there fails? What do? Do you just crawl into a corner and cry? I mean, not you might do that as well, but I'm talking about your applications. If your application does that, maybe you will do the same, but don't go there. So then you want to have something like observability. You want to actually know how your application is doing. You want to be able to see some kind of regular metrics, default metrics, custom metrics, different kind of things. But you want your application to be observable. You want to, like, for example, trace your calls through all the pieces and bits and pieces of your application, right? And there is this big chunk thing of that we traditionally, all of us, unfortunately, slap on the end. And that's the last one there, security. Probably not a good idea to do that at the end as well, but that's a different kind of story. So we're not going to go there either, but think about that early. See, I thought about it early. It just came last on the list, right? And the last thing is that people very often do, and sometimes often even misunderstand, is this lock-in thing, and to avoid lock-in. And sometimes they just go really overboard and kind of crazy for avoiding the lock-ins at all costs, and for kind of really weird reasons. Like, for example, saying like, oh, well, we cannot run this managed database solution It's a regular database. It's like MySQL or Postgres or whatever. It's just a kind of standard thing, but somebody else is managing it and it runs on a cloud. Oh, no, 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 no. We cannot touch it. We need to install a VM. We need to install that ourselves. We need to struggle with setting it up. And, but then we do not have lock-in. And then you would be like, is it though? Like, is it a good idea though? If it's a standard tool just managed, maybe it's a good idea to use that. But again, that's a different kind of story. So, all of those, most of those circles up there can be a topic for a separate talk, right? So this is kind of the business needs that people often come. There are more stuff to it, of course. There are more like functional stuff and everything. This is kind of more into the non-functional landscape. But, this is the things that we want to solve very often as businesses. Or I work as a consultant, so customers come to us and ask us to do this. And this is what my kind of summary of things that they usually ask is. So now let's talk a little bit about what. So the what part is kind of going to be quick. We want to build scalable applications. We want to be able to deploy them somewhere. And that somewhere can be, well, 3. It's not a mathematical symbol. It's actually just arrows. So 3 things, right? Cloud, public, private, you name it, whatever. It can be multi-cloud, so different providers of clouds at the same time. It can be different reasons for that. It can be, for example, something that you want to do because your application is so important and so critical that you do not want it to go down even if data centers are on fire somewhere or, I don't know, sharks attack fiber optics over at the seabed or something. That one, by the way, is kind of a myth, but, it's kind of cool. Sharks with laser eyes attacking things, just imagine. But, imagine those sharks exist and you have a super critical application that, fights those sharks and you want to that application to be online all the time. Then you deploy to different clusters, to different cloud providers, and then your solution is available because you need much more sharks to take all the cables to kill it, actually, your solution. The other reason for that would be kind of a bit more realistic one, that for most of us, that's the costs. The other reason is that, one cloud provider has a hosting and databases and stuff really cheaper, depending. The other one has a much better, machine learning or something. The third one has a data warehousing that is really, really cool. The fourth one has application running and container hosting that is really, really easy, cheap, whatever. There can be different reasons for that as well. And the last way of deploying things is typically as a hybrid cloud. That's a cloud plus your own server racks. That's your server racks. And that is a way of doing that as well, because sometimes you don't want to share your data. So you want, most of the times you have to, you're forced by something, by laws, by whatever, to not let your data go somewhere out. You have to store it, you borrow some capacity at the cloud, you do some processing and stuff like that, and then you bring data back and store it. Sometimes it's just hardware. Sometimes it's just like you're using something fancy that does not exist in the cloud. GPUs, whatever, some special kind of hardware. Sometimes you're just not done yet. You haven't migrated everything yet, so you combine that as well. So that's the what part. And now it's the how part. That's kind of the fun part. That's where all the tools will be coming in and will be joining us in a few minutes. So the how part. The most obvious one is loose coupling, is this loosely coupled application. So you don't, by that I mean you don't have a huge monolith that is deployed out there, shoved into a tiny little container, Have you tried like pushing an elephant into a little container? That's what people do with monoliths. They just like put it in a container, barely close the door. It's like, we're cloud native. You know, it's always fun to think in images. And when you kind of imagine the whole thing, just like, you know, shoving an elephant in a tiny little box. But, you know, actually, speaking of cats like to do that. Have you seen this tiny little box and cat trying to get in? That's, yeah. But it's not easy, right? Now, all of a sudden, you have to split that monolith into microservices. You have to think about how do you want to split that. You want to think about the architecture of your stuff. You want to think about how your APIs are looking, both externally and internally, because all of those things have to communicate. What standards, what communication things? I mean, are you going REST, gRPC, carrier pigeons? There was a talk yesterday about mentioning those. You know, it's basically TCP implemented in pigeons. The package loss is a bit heavy, but well, again, I'm going off the script again. You need to think about APIs. You need to think how they look, what standards, what everything, right? You need to talk and think about service meshes and everything, because it's not just enough to deploy it on a platform, because now all of a sudden you need to do certificates, all these things, and then you end up with more sidecars than you will, more and bigger sidecars than your containers are, right? Another thing is that, well, speaking of containers, it's actually the container part, right? Because it's kind of obvious, and we don't really need to spend that much time up there, but the main thing that I really want to mention is that it's about reproducible both builds and deployments. Very often we think about one of them and forget about the other one. It's like, oh yeah, but you know, it's really amazing because you can deploy anywhere. Yeah, cool. But it's also reproducible builds. So it's actually both. And that usually leads to avoiding lock-in. That's the little unlocked lock thingy. And very important part here is actually automation, and that's what I mentioned already. You know, you want to automate the automation of automation because you don't really want to touch that thing. And I talked to somebody yesterday, I think it was Alex, and he was like, oh, you need to mention that because all of us developers, we really love ClickOps. You know, we have like a solution where you can just drag a jar and drop it into a web page and it just gets deployed, and everybody's like super happy because all of us developers, we just don't want to do all the you know, what do you call this? You know, any XML files, JSON files, YAML files, whatever that you have to write and deploy and do some. You just like drag and drop and say, magic. Yes, but it's kind of back in the days that was called black magic. People got like burned for that because you do that, and next time somebody else have to do that. They have no idea what magic rituals that you have to do before you drop that jar on that magic holy website. So you really need to document all that, and there is no better way of documenting that than actually documenting it in the code, in the script, and automation way. Automation is not just automating away boring things. It's also about documentation, and you can actually track the changes and track, you know, whatever deployment, whatever. Why is not it worked yesterday? Now it's not working. Oh well, let's go and check the deployment script thing. What changed there? Oh yeah, that line changed. Okay, that makes sense, right? If it is documented. If not, you're in trouble because you still don't know what kind of rain dance or whatever things people do when they deploy stuff on Friday evenings, they have to do to make it actually work, right? So less time, less errors, and less boring stuff, right? Resilience, we mentioned that already, so I'm not going to go too much into that, but this is already, we're not on the business needs part, but actually on how things, right? So to actually achieve resilience, so you have to kind of think about it in the opposite way, right? To achieve resilience, you need to have fault tolerance, you need to have observability, you need to have thought about security in various ways. We'll talk about like all this, well, most of those security things in a bit as well. And the last thing that I actually originally had as a, the last point actually did say serverless. I changed that to scaling because it not necessarily have to be serverless. I put serverless at the bottom there, or well, somewhere in there in the list, because it's actually about scaling your applications. You do not want to have an application that is running and consuming a lot of resources when there is no need for that. Again, you have less toil, so less kind of problems with your application, less boring stuff, but it's also about doing things, well, serverless is a kind of manage less. So you have less management, you have less resources consumed, you have, you basically scale down to very minimal or zero when you don't need your application and stuff like that. So that's where the money part comes in. But it actually does not necessarily have to be money. You can run serverless and you can run scaling, you can run all of those things on-prem as well. And to do that, when you do that, when you run it on-prem, now we're talking about resources and not money anymore. Well, money is a kind of resource as well, but it's one thing is like somebody's credit card is getting really warm and melting somewhere. The other one is actually servers are getting very warm and melting the earth, the climate and stuff. So it's all about, there is a kind of a bad joke there. It's always about something green, but two different kinds of green. Green computing and green papers. You're supposed to laugh. Yes, thank you. All right. So the how part about this is what I actually promised, right? The tooling part. And that is, this part I want to make it a bit more interactive as well. I'm going to mention some things. I'm going to talk about some tools. And I want you to shout out some things that are probably missed and you think should be there. And also I want... it's not necessarily I'm going to know what that tool does because there is a gazillion of them and there is a lot of them. So I might ask you what it is, but we'll get through this. Okay. So back to our 1, 2, 3, 4, 5 thing. So loose coupling. To do loose coupling, you have a bunch of now you've been upgraded to Captain Cat Herder. Because we're talking about cats, right? Cat herding is a fun thing, especially when you have microservices. They're all running in all directions. They have different container clusters and namespaces and all that. And congratulations! Now you have to have an overview of all of them. So few things that kind of want to mention here is there are things like you can do for dependency inspection. So that's like PMD. Is really nice. You can actually see how things are connected. JDEP shows you also dependencies that you're using. There was somebody had a talk yesterday that they showed really, really nice tool which can do also right out of the IDE, I think it was IntelliJ. So also really nice way of analyzing your dependencies. But so you need some tools to analyze your dependencies. If there are any other things that you want to mention now, that's probably time to shout out anytime, really. I'm gonna stop when I hear someone. And I kind of can barely see you all because of the lights. So sound is a thing. Another thing is that, we need to have some kind of, when we do loose couplings and all this, we need to have some kind of service meshes because Kubernetes does all the scaling and all these things. But then now we need something that can do all the certificates and everything because now we're communicating over REST or whatever else that is. And now we have to do HTTPS because we're very security-aware people. We care about security. We care about zero trust. We do all these kind of things. And now we have to do that. I don't know if you've seen, I don't have that picture, but there is a picture of a guy on a motorbicycle, like a tiny little guy on a motorbicycle, and there's like with a sidecar. You know where I'm getting now, right? With a sidecar on a motorbicycles, you know, the one thing with the one extra wheel. And there is like a really huge guy sitting there in the sidecar. This is what we end up with, like, you know, Istio and all that. You have tiny little container and a huge sidecar, at least one, maybe even more, that does all the certificates and all the security and all the other black magic that happens. But you know, you need to think about all those things, and maybe you need that, maybe you don't. And then you have things like what else? Yeah, obviously we have APIs. Now we have to handle APIs. And for that, we need some standards for doing that. And that's OpenAPI is a really nice standard. A lot of things are built on top of that, like Swagger. But all in all, all in the back, it's an OpenAPI. And it's implemented in a lot of places. Things like, I don't know, Spring, micro profile, all those kind of things just usually would have this API, OpenAPI endpoint documentation slash description slash all kind of things. They will have something like that, right? And then you need to do some testings and to do some testing, sorry. And for that, you know, unit testing and all this, you know, you have JUnit, you have Gatling for, you know, the performance and like, what do you call that in English? Yeah, well, load testing, that's what it's called. Test containers is a really nice thing because you can just create disposable containers. You create a container, you talk to it, you do stuff to it, and then when you're done, you just throw it away, and then, you know, you create a new one whenever you need. Anything else that you want to add to that part? No. Okay. Oh, yes.
Okay, we're going to talk about the losing company.
Yes.
But now I have a lot of dependency in the
yes.
servers.
And that's exactly, yeah. So the question is, how do we do this? Because now we're creating a lot of dependencies that we don't have that much control of, and because well, there's a lot of microservices, and how do you succeed with that? Well, you know, you have to pick one of the things, right? You can deploy everything in one monolith and just let it be there. Or you want to do microservices, then, you know, it comes at a cost. It's not just a magic solution. But the thing is, for both of them, you actually have the same problem. It's just like how dependencies are coupled. Because for a monolith, you would have typically a Java packages or, you know, whatever artifacts or things, and they would be. I worked in a really, like, relatively big projects with Java and kind of legacy now with, I don't know, 400,000 lines of code, 500,000 lines of code. It will be the same, right? We would have packages. How many of you remember something, something, something .util? Yeah, there you go. How many of you have tried looking in what direction and how things are pointing into util and from util? And how many util.util packages you have inside your monolith application? Yeah, a lot. Yes, that's the correct answer. And that is the thing, right? So you have already there, you have a lot of dependencies. And for that, that's why I'm mentioning, you know, things like PMD and JDEPs and all these things, because you can actually print them out and visualize them somehow and do that. Because most of the, like, at least JDEPs is a command line tool. It's just going to do your ASCII art of your dependency tree kind of thing. But, you know, it's still something you can build on top of that, or there is something built on top of that. That's what I'm saying. Please keep giving me tips and tricks, because there are some things probably I haven't thought about. By the way, this is the first time I'm doing this talk as well. So, you know, it's always continuous. well, you run CI/CD on your talks as well. So you do continuous improvement, you deploy a new version, and then next time you do a little bit better version of that. So, but yes, the dependencies are hard, and you need to visualize also your clusters, your traffic, and all these things. And some of the service meshes have that. Like Istio has a really nice visualization of things. It's probably kind of a bit hard to set up if you have to set up yourself, and there is a reason people go to other things like Linkerd and stuff like that, all these other meshes. But you need something to visualize it. So that's the kind of the tooling part. Okay, containers. There are a lot of different ways. So kind of most of us connect containers with Docker. It doesn't have to, because you can just basically run all the other ones, and most of them are mostly compatible. But then you have like Docker, Docker Compose, Docker, well, desktop as well, but that's a different story, right? But then you will have something similar for Podman, for example, which is made by a totally different, by Red Hat. You have Podman, Podman Compose, and Podman Desktop. Podman Compose is a bit funny story. I think it's, if I remember it correctly, it's still maintained by community stuff. So it's not actually an official thing, but it works. So what I did on my machine is basically, because Docker still sits in the muscle memory, so I created an alias, in my shell script, in my terminal. It says alias docker equals Podman, and then I don't have to think about it. And I did the same thing with Compose, so I just run Podman in the background, but I still do docker ps a whatever, docker run and kill and stop and all that. There is also things like Rancher. There are a bunch of other things to run containers. You just pick something, see if it works. If it's not, just go to something else, because most of those containers are actually built on this same standard, so you can actually move around and try different things. Not necessarily always, but at least you have a bit more freedom there. Yeah, we mentioned already things like service meshes already, and that's the two examples. There are a bunch of others. There are a gazillion of different service meshes out there. Some of them are very complex and very feature complete. Some of them are very simple and not that crazy. And most of the cloud providers, if you're running on public clouds, whoever that is, Google, Azure, AWS, whatever, you can do the same thing. They will provide some kind of service mesh that is managed, that you don't have to think about, and so on, so on, so on. But the point is, for containers, you also need some kind of tooling for that. I tried running everything on, for example, we'll get to that. I'm not going to tell that yet. Okay. Automation. And automation comes in all different shapes and sizes. You want to automate your builds, obviously, because back in the good old days, I worked on a project actually still already on the 2000 sides, or actually kind of late 2000. What was that? 2011, 12. Back then, it was already a legacy-ish project, but all the builds, everything, it was a Java project, huge, enormous Java project, and all of the builds were still made and kind of happened in bat files. Have you seen a folder full of bat files with go-tos? Yeah, I mean, what can possibly go right? And that thing has been running for 10 years, and sometimes all of a sudden you just need to change something, and it's oh, well, we're not building the class path right. What do we do? Oh yeah, we're actually building that class files through those 15 bat files with go-tos. So yeah, we need to add echo at the end and see what it looks like. Oh, it's wrong. Okay, how do we debug that? Well, Notepad it is. So, don't do that. We don't have to do that anymore. So we have Maven and we have Gradle. We have all these kind of tools that actually build these things for us and stick to those. Bat files, no. And then you have built and deployed tools, automation stuff, right? I realize that I should have added here at this point all these infrastructure as code things as well, probably. But okay, so we have things like Argo CD, GitHub Actions, any kind of action, something, whatever you're using to. GitLab has its own things. There used to be a bunch of others like Circle CI, whatever, all those things that are kind of either deprecated or half deprecated nowadays and been replaced by something else. All of the cloud providers would have some kind of their own ways of kind of near builds where you do, Google has Cloud Build, you have similar things in Azure, you have similar things in AWS, all those kind of things. Jenkins, good old Jenkins that we've used for ages, and it's still live and kicking. All these kind of things will help you to automate, but it's also about automating, for example, deployments. It's also about doing red-green kind of deployments or canary builds or stuff like that. Or it's about managing your traffic. So sometimes you don't want to deploy a new version and just route 100% of your traffic just over there. It's probably not a good SRE thing. Now we have to think about being an SRE as well, right? Because now we're doing DevOps and Dev star ops, anything in between, right? All magic, DevSecOps, I don't know, pizza ops, whatever. But the point is that we need to think about things like being an SRE, so site reliability engineering. So you want to make things reliable now. And for that, you also want to, for example, route a little bit of your traffic to a new version. See how it behaves, how people are using it, if it gives you errors, if people complain or something. Maybe route a little bit more traffic and a little bit more traffic, see how it behaves under pressure, and then route 100% of it. This can also be automated, right? But sometimes you don't want to automate that, but there is a tools, and I would put it either in that category or in something that comes next. Because now we talk about the resilience, and now I'm literally running out of space here. And that's because there is a lot of stuff. And one thing is that you need to think about failovers and circuit breakers and all these things inside your code. So this is a fun thing. So now all of a sudden you have to think about what happens. I'm running a bunch of microservices. I'm using a microservice out there that I don't have a control over whatsoever. What do I do with that if that fails? Do I just everything crumbles, grinds to a stop, and just dies? Maybe not. Maybe I should do fail tolerance. Maybe I should have failovers. So if something fails, I do fail over to something that is less resilient, or less precise or less something, but it still works. And I still give a user some kind of experience. Maybe degraded, but still some kind of experience instead of 500. But you need to implement that. You need to think about that. You need to think about things like maybe exponential backoffs. So if something is down, you don't want to hammer it with requests because you will end up DDoSing your own application and just killing your own network. You want to think about, all this, what else? Fail tolerance, backoffs, circuit breakers. So when you don't, when you try and, when you do some X amount of retries or something else kicks in, some kind of rules, and then you just okay, I'm not going to try this anymore, it's broken. All these things really need a tool. And there is very often, most of the things are kind of implemented based on Resilience for J, but there are different. They come in different flavors. So MicroProfile has its own spec that describes how you do all these kind of things, but it's up to providers of runtimes to implement that. So there is a Wildfly, there is a Helidon, there is what else? Tommy, a bunch of different Quarkus, all those things, and they all implement their own stuff. Most of them will be Resilience for J-based stuff. Spring Cloud has its own things, Micronaut, you name it. All of those will have something kind of tooling and ways of doing this resilience part. Then we come to the other bulk.
There's one more thing.
Yes, one more thing. Perfect.
About this resilience.
Yes.
We can always use service mesh, and that way we don't have to program it on our own.
Aha, okay.
There's another way to do it, and a way that can be used by many different applications, not only written in Java, but also in Python.
Yes.
etc.
Oh, that's a very good point. So the comment was that you can also bake in the resilience into your service mesh and let the service mesh handle it, because then you create one set of rules and everybody else is getting to use that and everybody's happy. That's also a very nice thing. But yeah, you have to think about on different levels, because this is on the network level and this is really, really cool. But if you're running something that's outside your service, I'm not sure, can you do that? Can it handle things outside the mesh? So if you're using like a third party,
It understands the HTTP codes.
yeah, okay, cool. So yeah, so it understands HTTP code. So if you actually run things externally, so you can also do that. That's really nice. That's a very, very good point. So thank you. Perfect. That's exactly what I wanted. I want everyone, I don't want this to be a broadcast, even though it looks like that. I'm standing here, you're sitting there, but you know, it's actually a conversation thing. Right, observability. So now we know when things go bad and we can handle all that and all this, and it's just peachy. We need to observe things. There is a lot of ways of doing that, right? There is OpenTelemetry, there is Micrometer. You can also do like Jaeger and Prometheus to collect all that and data. To collect all that data and then you put it into Grafana or something like that. There is also a thing called a Loki, which is a kind of a thing on top of Grafana. It's actually, well, made by Grafana, so if you search for Loki, you will find a lot of Nordic gods, but that's a different story. That's not the one you're looking for. It's look for Grafana Loki and you'll find it. It's more like a place where you put logs and stuff. Kind of different story, right? It's not very Avenger kind of thing. But still very useful, very hero on its own and all this, but a different thing. So yes, usually whatever you're using, if you're using those things on top there, microprofile, Spring Cloud, whatever, they will have their own ways of exposing that metrics and also connectors to connect to other things, or if you're using some kind of third-party provider for collecting all that logs and everything, they will have their connectors for whatever you're using as well. So you will need to pick one of those, and that will be a gazillion of tools. So, you know, seriously, I don't have space to put all of them, but there's a lot. A quick theatrical break, because in case you want to add something. Yes? Come again? What? Some kind of?
Alerting systems.
Oh, alerting, yes. That is a very good point. So yes, thank you very much. That was, yes, I need to add that. Alerts, so alerting systems, anything that gives you message, email, a phone call, a very, very big, scary guy with a bat, baseball bat at your door, whatever, you know, but if something goes wrong. But then it's also very important, that's a very good point. And another thing is that when you do that, you need to create just enough alerting. Too much, and you will just ignore everything. Too little, you will not see things happening. So you need to adjust this thing all the time. It's not like write once, configure once, and just forget about it. It's about continuously checking and improving and making sure. That's a very, very important part of this thing as well. Thank you again. Okay, and the last thing is the security in this bulk, in this group, is you want to do some kind of security scans. And you want to do security scans like static code analysis, like, for example, SonarQube or something else that does static code analysis of your code, so you do not have vulnerabilities or something like that. Then you need to scan your third-party libraries to make sure that these third-party libraries do not have vulnerabilities and stuff like that. Log4Shell, anyone? Okay, but you know, all those libraries might have vulnerabilities, and they probably do, because we're developers. We do create bugs. We convert coffee into, some say code, some say bugs. So it's yeah. But I'll say a bit of a mix. But this is human thing, right? We do make mistakes. You need to scan for that. You need to scan for your containers. You need to do some kind of, there is a Snyk, Aquasec, all those kind of things. Third-party companies that do also container scanning as well. They check if your that little layer of operating system-ish thing you have in the container may have a vulnerability, or whatever you put on top of that may have a vulnerability. So they do scan for that as well. Scans for network breaches, anomalies, all these kind of things. So it's very many levels here, right? Because you have your code, then you have your container around it, then you have your platform around it, and then you have all the other stuff like network and all these things around that as well. And then you have the big scary internet. Scan all levels thing, right? Any comments on this one? Security? Do not add it at the end, please. Scaling. So yes, the thing that has been renamed from serverless, because you want to scale, but you don't necessarily need to have full serverless. And here, it's probably a good idea to mention, because I mentioned Kubernetes quite a few places here, and a lot of things that are like Kiali and there are a bunch of things, Keta, all those things are based or built in the Kubernetes something. So the Ks often stand for Kubernetes something. Look at your application and make sure that you actually need a Kubernetes. Do you really need the 3-node monstrosity running there for a tiny little microservice that has 3 users on average? I mean, yes, I know your application is very important and super cool and fantastically amazing, but 3 nodes though, right? So maybe you actually need serverless, or maybe you need to put it onto something smaller that scales up and down and stuff like that. So Knative is one way of doing that. So it's a kind of a thing on top of Kubernetes, surprise, surprise, on top of some kind of service mesh. It used to be only Istio, now it's a bunch of things. And yeah, so Knative is one thing. Keta is another one that is actually stands for, again, surprise, very big act surprise now. It stands for Kubernetes Event-Driven Autoscaling. Hey, yay. But that's pretty cool because it's a kind of alternative, and here you can create autoscaling based on very custom metrics. So that's really nice. So you can actually add your own metrics to things you want and scale based on that. Like number of scrolls on a website or clicks or something. Oh, 10 containers, right? I believe, correct me if I'm wrong, but I believe you cannot, for example, do this kind of stuff on Knative, for example. Yeah, so there is also ways of running containers, full containers. I'm not talking about like serverless functions and stuff like that, but there are ways of running serverless containers, like full-fledged application kind of containers on clouds, on public clouds as well. So you have Cloud Run, you have things like Azure Container Apps, and so on, so on, so on as well. And here, it's probably also a very good idea to mention that you also can do multi-cloud. There are multi-cloud tools as well. So there are things like, I don't know, for example, OpenShift, or so Red Hat has OpenShift, Google has Anthos, and all those kind of things that let you run things across clouds. So you can run some of your loads on Google Kubernetes Engine. Some of them can go to Azure. Some of them can go there and here and everything. And it will kind of seamlessly do the network magic, because IP tables is a bit pain. No? Yes. Okay. One person agrees with me. Thank you very much. That's more than that. I mean, that's all. Yeah. I'm happy. All right, IP tables. I ended up once trying to figure out how you calculate slash notation by hand with binary. It's really fun when you figure out how it is. You start questioning your life choices when you after you do that, but that's okay. We can do that after this talk. We're almost done. So. Resources, a kind of a bit of a shameless plug kind of slide, but I've put some, I've recently, just literally like 2 days ago, written a couple of blog posts about cloud security stuff and things to think about when it comes to cloud security. So you'll find them there. Very creative names, Cloud Security Principles and Cloud Security Principles 2. And I also have a repository that for another talk that I usually do about things like fault tolerance, metrics, health, feature toggling, and all this with micro profile and actual code, and that is in there. And you will find everything, just find a README and everything, and it's going to be there. And with that, I would like to say thank you very much. And this is me, and this is me on Twitter. If you want to find me on all other social medias that are supposed to take over for Twitter, I put them all on that website, including Twitter or X or whatever that thing is called, and that QR code goes to the same thing. Thank you very much for being here.